Hey everyone, we're going to pick up with units of concentration in our Chapter 9 lecture slides. So we had previously done a Henry's Law problem, and the slide I'm talking about is right after that. Just to give you a heads up, we are going to cover 6 topics today. Okay, so units of concentration will be the first one, but I'm not going to be spending 20 to 30 minutes on any one topic. Okay, we definitely have more problems packed into these slides than I have time to work, so I will work a few examples of each topic, and then I will come back to the ones I skip over before the exam whenever I do a review. Okay, so I've actually introduced this concept back in Chapter 7 when we talked about the equilibrium constant K and plugging in concentrations to the equation for K, so you have seen something very similar to this slide, but we're officially going to get into the details of it and work some problems with these equations. So concentration, what is it? Well, when you're talking about a solution, which is what Chapter 9 is all about, it essentially is an amount of solute per volume of solution, okay? And we have defined these terms, solute and solution. The solute is what is being dissolved into the solution, which contains the solvent. And there's a few different ways we can represent concentration. Not every way is represented on this slide, but this is the 2 ways we'll learn and use, and 2 units of concentration that are used very commonly. So the first one is known as a weight volume percent. We can convey concentration via a percent. So you could have a 20% sodium chloride solution or a 20% glucose solution or something like that. So notice that weight is a unit of mass. Obviously, volume is going to have units like milliliters and liters. And this makes sense when you have a solid dissolved in a liquid. Okay? Remember that solutions can also be solids dissolved in solids or liquids dissolved in liquids. And if that's the case, it might be a volume per volume percent or a weight per weight percent. Okay? So this is a weight volume percent when you have a solid dissolved in a liquid. So the way the units work out here is that we're going to measure the grams of solute and divide that per the milliliters of solution. And then we always multiply it by 100 over here to turn it into a percent. Okay. Remember that the solute will be a lesser amount than the solvent. All right. So that's why it will always be a decimal. And then you multiply it by 100 to get that percent. So I have this picture on the far right of like an IV, and this is something that, especially if you're going into the field of nursing, you're going to run into IVs, and these IVs have, or they might call them drips, things that we're putting into the body to hydrate it. Sodium chloride, saline solution. You might be, I know women who get epidurals in child delivery might get a drip of a powerful drug. Okay, so you have to know concentrations of those things to make sure that the patient or whoever you're working with is getting consistent concentration over time, which is why they're doing it via this IV. But then what that concentration means, okay, so that you know how much of the total drug or solute that they're getting in their body. And then this note down here, nurses work with molarity, which is the next concentration we're going to talk about, specifically dialysis lab work. Okay, so you will run into units of molarity if you're working in a hospital for sure. And this is just one example. So molarity is, you can abbreviate molarity with a capital M, but it is moles of solute per liter of solution. And you guys are familiar with what a mole is, and obviously a liter. So just know that these 2 equations have different units, and let's do some practice problems with these. Well, after I give you the details on how to properly prepare a solution. Hold on, excuse me. Okay, so quick note on how to properly prepare a solution. So I'm going to read this little line under the title. It says, the volume of a solution includes both solvent and solute. Okay, your solute contains a volume. Usually we think of the volume coming just from the solvent, but it's also the solute. So the way, like, we call this right here of this glassware in this picture right here, we call this a volumetric flask. And obviously you see a hand pouring some yellow solute in it. Okay, so step 1, if you're preparing a solution, is add solute, all of your solute, whatever you're going to dissolve. All right, and you can see that this is a 250, you might not be able to see it very well, but it's a 250 milliliter volumetric flask, okay? So it'll hold 250 milliliters of liquid. And the next step after you add your solute, step 2, is to add some, so I'm going to underline this, some solvent. Okay, we don't add all of our solvent. Why? Well, because if we just add all of our solvent before this solute, this yellow powder, has dissolved, we would end up with a solution that was not the right concentration. Our volume would be too large if we added all the solvent, okay? Because we would have the volume of the solute, which is not dissolved, plus the volume of the solvent, and your volume would be too large. So you add some of your solvent, and then you mix it to dissolve the solute. That way the volume is adjusted. Whatever the solute is going to add to your total volume, that's dissolved in there, that's accounted for. And then step 3 is you add the rest of the solvent. Okay, this is very, very important. You can see here that we have some sort of pipette, some fancy volumetric pipette, dropping in, drop by drop, very carefully, the rest of the solvent to get exactly the right volume so that your solution is exactly the right concentration. Okay, so if I were to ask you on the exam, tell me, how do you prepare a solution? I would want you to walk me through these steps. All right, now let's work some problems. This slide right here kind of hits on what I was saying on that first slide, where I was talking about not all solutions are a solid dissolved in a liquid. So what units would we use to express the concentration of a solid solution, meaning a mixture of a solid mixed into another solid? Okay, if we were doing, this would be a weight per weight percent, not a weight per volume percent, and that would be grams of solute over grams of solution times 100. Next question says, what units would I express the concentration of a solution made by dissolving one liquid in another? So you have a liquid solute this time and a liquid solvent. This one would be a volume per volume percent, and you would use milliliters of solute over milliliters of solution. You just see how the units here match whatever your state of matter, or not state of matter, but whether you're dealing with a mass or a volume, okay? And then obviously times 100 again to turn it into a percent. This right here, if you do the problems that I recommend in the back of the textbook, there is a great problem, and I usually always work it in a review before the last exam 4. It's about Listerine. That's mostly what I remember. Listerine is like a mouthwash, right? And it's got alcohol dissolved in it to help clean and sterilize. And so the amount of alcohol dissolved into the Listerine, it gets at that. So anyways, this is the equation you would use to help work that problem of volume per volume percent. All right, now we are going to work a few problems using specifically our weight volume percent equation, and then we'll work a problem with molarity. Okay, so this first question or problem says, what is the concentration in weight volume percent of 15 grams of glucose dissolved in a 100 milliliter solution? So we are searching for the weight volume percent, which is this part, and we're going to plug in grams of glucose. Here, I'll just highlight. We're going to plug in the 15 grams of glucose. That's going to be plugged in right there for grams of solute. And then we're going to plug in 100 milliliters of solution right here and see what we get. So the weight volume percent is going to be equal to 15 grams. This problem is honestly too easy for you guys. And you say times 100. Okay. So some of you are grabbing your calculators right now. You should, at least. You'll want a calculator out for the rest of this video. But 15 divided by 100 times 100, you might notice that these units cancel. And so it just ends up being 15%, right? Now, you might be asking, what happens to the units, a gram and a milliliter? When we convey, that's why it's so important to convey the W or the V or 2 W's or 2 V's or whatever it is, because it's understood, and we only write the percent side, it's understood that this is a gram per milliliter percent, okay? So we don't have to write that because we might say that it is a weight per volume percent. Now, you don't have to write this out because I'll know when I write the question what information you're given. You only have to write percent, but the units do not just disappear. They're still conveyed with this understanding of what kind of percent we're saying it is, okay? But you just write percent. You don't write the G per ml. Okay. Next question. If I dissolve 180 milligrams of heparin, I always usually pause and ask students, who knows what heparin is? I actually worked with it a lot in graduate school in my research, and it's part of the blood clotting cascade. It's a blood thinner, so you might know somebody who is on a blood thinner like heparin. So it works against blood clotting. But if we dissolve 180 milligrams into 15 milliliters aqueous solution, what's the weight volume percent? Now, again, look at your units. One thing you might notice here is we're not starting with units of grams like we did in this other problem. We started with 15 grams of glucose here, we're starting with milligrams. And our equation says it's got to be grams of solute per milliliters of solution. So before we just go plug these numbers into the equation and solve for the percent, we first need to convert this to grams. And this should be very easy for you guys. Okay, 180 milligrams. Do you guys remember how many milligrams are in a gram? That's the info you need right now. 10 to the power of 3 or 1,000 milligrams for every 1 gram. So you calculate that. Essentially, you move the decimal place 3 places to the left. So 0.18 grams of, I'm going to put hep for heparin. So that's our mass, and now we have our 15 milliliter solution. Now we can plug everything in and solve for the percent. So you would say the weight volume percent is equal to, I forgot the 0.18 grams of heparin over 15 milliliters of solution times 100. So again, grab your calculator, work this out. 0.18 divided by 15 times 100. You should get 1.2%. So double check me. It's always scary when I do these video recordings because I don't have anybody to double check me. So I hope these answers are all right. Okay, what was I going to say? Oh, last thing. What if I would have given you, what if instead of telling you 15 milliliters, what if I told you that you had, 1,200, or, 1.2 liters of aqueous solution, okay? If I would have given you milligrams and liters, just like we converted the milligrams to grams, all you'd have to do is convert that to milliliters before you plug it into your solution. Okay, so again, even if I give you different units than what your equation calls for, convert it always to grams and milliliters. And those conversions should be pretty easy for you guys at this point. All right. Okay, I'm going to do one more problem on this, so I will come back before the exam and work this practice problem, but I'm going to do this one because it is having you solve for grams of solute. It gives you the percent, which is a great practice because I could give you, essentially, I'm going to highlight it. There's 3 variables to this equation. There's the percent variable, there's your milliliters variable, and there's your grams. And I could give you 2 of the 3 parts and have you solve for the third. You're not always going to be solving for the percent. I could give you the percent and have you solve for grams, which we're going to do in this problem, or I could have you solve for, I could give you percent and grams and have you solve for milliliters. All right, so how many grams are needed to make 0.25? Look, we do have liters here, so we're going to have to convert a 0.25 liter solution of a 1.5% weight per volume. See what I mean? They're conveying the weight and volume, so it's an understood gram per ml right there, saline solution. Okay, so we want to go ahead and plug in 1.5% equals grams. This is the part we're looking for. Okay, so I'm going to put a little question mark here. Per milliliter of solution. Okay, and this is our volume, so we need to convert that before we just plug it in. So I'm going to take 0.25 liters, and I'm going to move it down so that I have space. We know for every 1 liter there is 1,000 or 10 to the power of 3 milliliters. So it should be, move the decimal 3 places to the right, which is going to give you 250 milliliters. And this is what I'm going to write right over here, 250 milliliters. Now you still have to write in the times 100. That does not go away. It's part of the equation. And I want to solve for grams. So we're going to use principles of algebra and move everything over until we have grams by itself. So I'm multiplying by 100 over here, which means to get rid of 100, I need to divide on both sides. That's my first step. Okay, then 100 will cancel right here. So now I'm going to essentially undo my percent. 1.5 divided by 100. 0.015. Okay. And so now this equals your grams over the 250 milliliters. Now you have 250 milliliters on the bottom. You want to get rid of that, so you have grams by itself. And the only way to do that is by multiplying 250. You can write it over 1 if you want. So times, I don't have a lot of room over here, 250 milliliters on both sides. So now it cancels here and here. And we will do the 0.015 times 250. And you should end up with 3.75%. Oh, whoops, wrong units. Grams. Okay, now again, you might be wondering, how do these units work out? And I just want to reiterate, because you're not seeing everything with this percent. This right here, let me scoot this over for just a second. This is a weight volume percent, okay? And we could even write that in, it's just fine, which means it's a gram per milliliter percent. That's what that means. So once we undo the percent, again, it's not very common to write all this in, but it is a gram per milliliter number. So now when I'm multiplying by this 250 milliliters, the milliliters cancel, okay? And that's why we're left with just grams, 3.75 grams of sodium chloride, okay? So we could write that in. All right. There's that problem. And again, I'll come back to this other problem before the exam. I encourage you to try it on your own and see if you understand it and feel good about it. Okay, this one you're solving for milliliters, which is the other part of the equation we haven't yet solved for. All right, let's work a problem on molarity. Okay, moles of solute per liters of solution. So it says I dissolve 2.335 grams of hydrogen sulfate, H2SO4, in water and dilute it to 50 milliliters. So this is the total volume of the solution. What's the molarity? Okay, this problem has a little bit of converting we have to do before we just plug everything in. We are supposed to plug in moles of solute on top, but we're given grams. Okay, how do I know this is my solute? Because it says I dissolve this thing. I'm dissolving hydrogen sulfate, which means my hydrogen sulfate is the solute. And the solution is going to be the 50 milliliters. We're supposed to plug in solution in units of liters. So a couple things. We need to convert grams to moles, and we need to convert milliliters to liters. And sometimes you'll have to do that. So we're going to need the molar mass of hydrogen sulfate, which for time's sake, I'm just going to look it up. On an exam, if I just give you hydrogen sulfate, you have the periodic table, you could calculate this. I say for time's sake, and then my internet's super slow. Okay, hydrogen sulfate molar mass. So it is 97.0715 grams per mole. Okay. So I'm going to take the 2.335 grams, and I want to cancel grams, so I'm going to plug the 97.0715 grams on bottom, and this is per 1 mole on top. And when we calculate that, we should get 0.024. If you round, it's 241. Okay, now I want to pause and reiterate on a video lecture, which I know some people hate and some people love it. You should be working these problems with me, not just staring at the screen, watching me do them. I hope you have pencil and calculator out. I hope you're working these with me. That is how you're going to be the most prepared, and that's how this lecture is going to be the most beneficial to you. So if you don't have those things, pause this video and go get them. But I would expect and I hope that you're all working these out with me as you watch this. Okay, the next thing we need to do is take our 50 milliliters and convert it to liters. So there's 1,000 milliliters in 1 liter. And when we divide by 1,000, we get 0.05 liters. And now we have the right units, okay? You see how it's moles and liters, which matches our equation up there. So I'm just going to take these and divide. I'm going to do the molarity is going to be equal to 0.0241 moles. And you can write your substance if you want. Hydrogen sulfate over 0.05 liters. We do not multiply by 100 here, like we did for the weight volume percent. So your final molarity should be 0.48. Okay, and this is understood. Molarity is a moles per liter. Okay, it's not that these units go away. It's just that they're they're understood. When you write 0.48 m, then people, once you're around this field enough, know, or I'm just asking you to know now. M means moles per liter, per 1 liter. Okay, that's an understood one. Okay, the number of moles in 1 liter of solution here is 0.48. Okay, so that's what this M means, is moles per liter. So the units don't just go away, they just are summarized with an M. Okay. All right. I think that's going to be all the practice we're going to do with these two equations for now. I will come back and do more, especially before the exam. But now I want to show you, so not a totally new topic, but I want to show you an application for using molarity as a conversion factor to convert between the two units within molarity, moles and liters, volume and moles. So just the way, you guys remember density, okay? I want to talk about density for a second. Density equals mass over volume, right? And so you would calculate the density in gram per milliliter or gram per cubic centimeter. And we practiced a whole lot using density to convert. I know it was on your chapter 1 homework. Using density to convert between grams and milliliters, okay? And the same idea, same concept, we're going to use molarity now to convert between moles and volume, or volume and moles. So this problem says a blood alcohol content of 0.065 molar is enough to induce a coma. And the total blood volume of an adult male is, on average, 5.6 liters. How many grams of alcohol are necessary to reach this concentration, right? And this would be just pure 100% alcohol. Obviously, people aren't just drinking pure 100% alcohol. So to actually make this more applicable or more relevant, you would have to figure out what percentage a certain intake of alcohol, like if you're drinking a particular kind of drink, you'd have to figure out what percentage of alcohol is this drink. And then you'd also have to factor that in, which we're not doing here, but that's okay. So we're going to start with the volume of blood given, which is the 5.6 liters. So this little diagram, this is right out of your textbook, because your textbook is very helpful for working problems out as well. And then we're going to use the molarity to convert from the volume of blood to moles, okay? Ultimately, the question is right here, right? How many grams of alcohol? So we're looking for the mass, that's what we're trying to find. ETOH is just alcohol. Cannot spell. This is just one way we abbreviate ethanol. Okay, so ethanol is the alcohol in alcoholic drinks. All right, now what are we going to do? So we're going to use molarity. Where's our molarity? Can you see it? Do you remember which number is our molarity? It's the one with an M. So this is our molarity. And I want to write this over to the side on the right side of the screen for a second to remind you 0.065 M means this, 0.065 moles per 1 liter. That's what that means. Okay, that's what the M means. So we're going to actually separate out those units now, moles and liters, because I want to cancel liters and I want to convert to moles. Then I know how to go from moles to mass using the molar mass, which I actually have written for us. It's the 46.07 grams per mole. So first I'm going to plug in for every 1 liter, there is 0.065 moles of ethanol. Okay, you can write that. And now, this is step 1, so we just used the molarity to convert. If you look here, liters cancel. So we have converted from liters to moles using molarity. And now I'm going to plug in the molar mass to convert from moles to grams. All right, so I'm going to plug in for every 1 mole, there's 46.07 grams of ethanol, which is the alcohol. And now we just multiply all this out. 5.6 times 0.065 times 46.07. Hopefully I did that right. 16.77 grams. Let me make sure. Double checking all my numbers. Okay, it looks right. Of ethanol. Okay. Now usually, so ethanol is a liquid, and usually it would probably actually be more useful to know this as a volume. So you could take the density and convert that to milliliters to see how many milliliters of straight ethanol could induce a coma. That's a very bad thing, so we want to stay away from that amount. Okay, that's that problem. So definitely on the exam, you will have to use molarity to convert.